So, hello, konnichiwa, welcome back for our next education training session. I'm happy to see that you guys are back on the training, and I hope you will enjoy the next step of education levels. We will go much deeper into the material of CHP control, analyzing problems, and so that you can actually do and analyze and solve problems by yourself. Okay, so then let's dive in and enjoy the video and the program. As usual, please give me a feedback on the video, on the content. If you have any questions, what we can improve on the video, what additional content or questions you have that we can put it in place so that we actually get you up to a high level of understanding and solving problems by yourself. Okay, thank you and enjoy the video. First of all, I had prepared on one of the CHP from corners a trend locking file. So we have here a trend locking file. This is from the newer version of the visualization of Schnell. But the content of the values are the same as the older version, only the diagram looks a little bit different, and but the values are all the same. So all the content and values functions are exactly the same. It's only the point of how it's shown up in the visualization. So don't get confused. I took this time one of the other plant. It's not Urimaku, but it's easy to compare with Urimaku as well. The functions are the same. The diagram looks a little bit different, but it's this diagram from the new visualization is easier to explain because we get more values on one screen. It was easier for me to make that videos for you. Okay, so here we have to understand. So I have done a screenshot of one of the gas operation. So this is a screenshot from the 24th of February 2022 at 5:10 p.m. And we can see here the whole process from start, synchronization, warm up, and load operation in gas mode. So remember, we have two kinds of modes. We have the diesel mode, pure diesel mode, and we have the gas mode with pilot fuel. Okay, this one, what I show here, is from the gas mode. First of all, I like to show you quickly. I have here put trends offline, scroll into the date and the time that I get a proper view on an operation. If I move me a little bit of the window quickly, so we can see here we have an operation start 11 minutes after 5 p.m. and stopped after approximately 23 minutes after 5. So it was a short operation in gas mode at that plant. So we will see all the process over the, let's say, 50 minutes after start, what is going on. This is the first step to understand the process. And we dive into the starting phase and go then through all the points. Okay, so now we go quickly into to our trans and why I put the trans values, what we can see here on top, in place. Because it's always important that we know what we like to analyze, in which kind of process we are, that we figure out that we have the right values what will show up here in the trans. We cannot choose all values what are available. That will be hundreds of different values. So we have to pick out of the listing the exact values what we need, what we like to see in our trans, and what we need to analyze the status or the problem. Okay. As I mentioned already, we like to go through the process status of the CHP, and I choose that values what you can see up here. So we go from the left to the right. So first we have the green one, that's the active power. We like to see how much kilowatt the system is operating if it's connected to the grid. So that's the green one. I have two green, but the green one goes up here. That's the load or the power. Then we have the pulse width, the pink one, that's that one. The pulse width is the time in microseconds. How long will be the injection open to inject diesel into the combustion chamber to ignite the biogas or to operate the CHP in starting phase. As well, to the injection system, we have the injector angle. The injector angle is the time when we start to open the injector. I will go into that a little bit deeper. You can see this is in degrees. So that means in degrees on what position of the flying wheel or of the crankshaft we starting to inject the diesel into the combustion chamber. So the red one here, it's going straight up and then stable on a high level here. This is the engine speed. So, and for that it's important if we like to see the synchronization or the startup phase, that we can see how is the speed of the CHP. Then again, to the injection system, we have the bright blue one, that's the common rail pressure. The common rail pressure is from the common rail, from the high pressure pump to the common rail before it goes to the injectors to inject the diesel. So now we coming to the values what we need for the synchronization. The blue one here, that's a different frequency. That means that's the frequency between the alternator and the grid. So this value must be in range or in limits before the system or the PLC of the CHP is allowed to close this generator circuit breaker to connect the grid with the alternator. Here the black one or dark blue one is the differential voltage. That's again for the synchronization. We have the grid and we have the alternator. This voltage must be again as well as the frequency in the limit that the system is allowed to close the circuit breaker to connect the grid with the alternator or the alternator with the grid. Dark green as well for the synchronization, the differential angle. On the grid we have 50 Hertz sinus curve of each phase, and the angle of this wave of the 50 Hertz wave of each phase of the grid must be synchronized with the angle of the alternator. So the alternator must be synchronized to the grid before this is allowed to connect. We must be in a range, I'll show you later, that the alternator get control, that the lines are lying almost over each other before you are allowed to connect. Then we have the closing signal of the generator circuit breaker. The closing signal shows a 0 if the signal is open, means the breaker is not closed. If the signal is 1, this means the breaker is closed. The breaker by themselves have then a response signal from the generator circuit breaker. So we're sending a signal first to close the breaker, and the breaker sends a signal back, a feedback or response signal to the PLC, and tell the PLC, I'm closed now. So, and then last but not least, we have here in another green, or in almost the same green, we have the gas blower, because we're running here on this trend, we operating in a gas mode, so that I can show you the gas blower control. We can see the gas blower control is in percent. As we know, the gas blower operates on a maximum speed of 50 Hertz. So that means in this case, if the output signal is 100%, that means the gas blower will run on 50 Hertz. If there is an output signal on 50%, that will mean we operate the gas blower on 25 Hertz. Sorry. Okay, so that's about the overview of the trend values. So, okay, so first of all, here we have the flow diagram of the CHP. I prepared that special for showing you guys the different steps what the engine has or the CHP has to run through. First of all, we have the signals. We have a start signal, stop signal, slow stop signal, immediate disconnect signal, and immediate stop signal, like emergency stop. This signal will interrupt that process. You can see the start signal kicks in here for the start. We have here the signal what will interrupt the process, like to stop the CHP or to disconnect the CHP or immediately stop the CHP. So first we have our process. So okay. First we have the start. From the start we go into the speed control mode. From the speed control mode we go into the stabilization mode. From the stabilization mode we jump over to the synchronization. From the synchronization we jump to the grid connection. That means when the generator's circuit breaker is closed. From the grid connection we go into the load control mode. From the load control mode we go in the warming or warm-up phase. After the warm-up phase we go in the load ramp up or increasing phase. After that we go in the load operation phase. So, and then we are, for example, we stop the CHP with a signal, we go into the load decreasing or load down phase, load reduction phase. After the load reduction phase, we go to the grid disconnection. That means that's the point where the generator circuit breaker disconnect the alternator from the grid. After that, we are disconnected from the grid. The CHP goes back into the speed control mode, and after the speed control mode, we have a short aftercooling if it's necessary, if the CHP is still too warm, and then we will have the stop or the standby mode. So these are that's the process what the CHP jumped through it. Always it could be that one of the signal can interrupt that process. That means if there is a immediate disconnect, we will jump, doesn't matter in which kind of mode we will be, we will jump immediately into the grid disconnection. So these signals here will interrupt that process. The priority of that signals are higher than the priority of jumping through the process. So if we get the signal of immediately stop and you are in one of this process in the beginning, the CHP will immediately jump down to the stop phase. So that's for the understanding as an overview. Please let me know if there are any questions. That is only a basics, that it's easier to understand how the system works with each other.